Number 6. We have here tangent x over 1 plus cos x plus sine x over 1 minus cosine x. Does this equal to cotangent x plus secant x cosecant x? Now, both sides look pretty complicated, so I can start from either one. Another strategy for doing these trig identity problems is to, if you start simplifying one side and you can't see how to make progress, you can always start from the other side and see if you can't meet halfway or in the middle. And I believe that's what we're going to have to do to verify this trig identity here. I'm going to start with the right side. So I'm going to write everything in terms of the basic trig functions, sine and cosine. So cotangent x, that is going to be cosine x over sine x. Secant x, that is 1 over cos x. Cosecant is 1 over sine x. In order to add these two fractions here, I'm going to have them have the same denominator. So multiply this first fraction by 1, and the point is that I can write this as cos x over cos x times cosine x over sine x. Multiplying these two fractions here, that's I have 1 on top and cos x sine x on the bottom. And multiplying these two fractions here, I have cos squared x on top, and on the bottom, cos x sine x. These fractions have the same denominator, so now I can add the two. So on the top, so the bottom has the same denominator, so cos x sine x. And on the top, I just add the numerators, so cos squared x plus 1. Doesn't seem like I can simplify it any further, so now I'm going to shift my focus to the left side. So I am going to add these two fractions here by multiplying both of them by 1. I want these fractions to have the same denominator so that I can add them. So on the left here, this one is going to be 1 minus cos x over 1 minus cos x times tangent x over 1 plus cos x and plus sine x over 1 minus cos x. And this one here is going to be 1 plus cos x over 1 plus cos x. So this first fraction is going to be, on the bottom, it's going to be 1 minus cos x times 1 plus cos x. On the top, I'm going to have 1 minus cos x times tangent x. And the second fraction here, it's going to be sine x 1 plus cos x over 1 minus cos x 1 plus cos x. These have the same denominator, so now I can add the fractions. On the bottom, it's going to be the same, 1 minus cos x 1 plus cos x. And now I just add the numerators. So this is 1 minus cos x tangent x, and then plus sine x 1 plus cos x. And now I distribute the terms in the numerator. So on the top I have tangent x minus cos x tangent x, and then plus sine x. So I don't have much space here, so I'm going to write this. So on the top here I have sine x times cos x. I'm going to write that over here. Sine x cos x plus. All right, and on the bottom, if I multiply these two terms on the bottom, I have 1 minus cosine squared x. I'm going to convert, so on the right here, on the right side, I have everything in terms of sine and cosine, so I'm going to get rid of tangent here. So sine x cos x plus sine x over cos x minus cos x times sine x over cos x plus sine x. And on the bottom here, 1 minus cos squared x, that is going to be sine squared x. Cos squared x plus 1 over cos x, sine x on the right. So this cos x will cancel this one here. And I will be left with sine x cos x plus sine x over cosine x minus sine x plus sine x over sine squared x. So these terms cancel out, and the right side stays as it is. Cos x, sine x on the bottom. Now, I am going to, let's see, I have a fraction on the top here, so I'm going to multiply the top and bottom by cosine x, and I'm going to distribute to both terms here. So on the top here, I have sine x cosine squared x plus sine x. This cosine here cancels with the one on the bottom, and that's why it doesn't appear here in the second term. And on the bottom, I have cos x sine squared x. Does this equal to cosine squared x plus 1 over cos x sine x? So now, I'm going to factor the numerator. Both of these terms here on the top have a factor of sine x, so I can pull it out in front. So if I do so, I have sine x. What's left over after I pull out sine x? For the first term, it's cos squared x. And after I pull out sine x, all that's left is 1. If I distribute this to both terms, I get what I started with, this. The bottom stays the same. So now that it's factored, I can cancel out sine x with one of them on the bottom. And I'm left with the desired result, cos squared x plus 1 over cos x sine x. This is indeed equal to cos squared x plus 1 over cos x sine x. And the trig identity is verified. So, a lot of work for this one. My goodness. Let's do one more. 7. All right, I'm going to have 1 plus sine theta over 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta equals 4 tangent theta secant theta. All right, so which side should I start with here? It seems a bit similar to the number 6 in that, Well, actually, the right side is simpler than number 6 because there's only one term. So I'm going to start with the left side here. I'm going to combine these two fractions by multiplying both fractions by 1. So to make the denominators the same here, this first one here is going to be 1 plus sine theta over 1 plus sine theta times 1 plus sine theta over 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta. And I'm going to have, for the second one, it's going to be 1 minus sine theta over 1 minus sine theta. Does this equal to 4 tangent theta secant theta? Now I'm going to multiply the two fractions here. On the top, it's just going to be 1 plus sine theta squared. And on the bottom, it's 1 plus sine theta times 1 minus sine theta minus 1 minus sine theta squared on top here. And on the bottom, that's 1 plus sine theta over 1 minus sine theta. All right, and now that the denominators are the same, I can subtract the two fractions. So one big fraction and the denominator will be the same, so 1 plus sine theta times 1 minus sine theta. And on the top here, I have 1 plus sine theta squared minus 1 minus sine theta squared. So now the left and the right side both have one term. Let's see now if the left side simplifies to the one on the right. So I'm going to expand the numerators to see if I can't cancel some terms. So this first one is going to be, if I square the first, that's 1. Square the last, that's sine squared theta. And then twice the product in the middle, 2 times 1 times sine theta. And now I'm going to expand the second term. So this is going to be 1 plus sine squared theta minus 2 sine theta. And the denominator stays the same, 1 plus sine theta, 1 minus sine theta. Does this equal to 4 tangent theta secant theta? Do any of these terms cancel? Yes, they do. So the 1 cancels with this one, and the sine squared theta cancels with this one. And the negative combines with the negative here to give a plus 2 sine theta. So on the top, I have 4 sine theta. And on the bottom, if I multiply this out, I get 1 minus sine squared theta. And let's see, so on the bottom here, that's going to be 1 minus sine squared theta. That's just cos squared theta. So 4 sine theta on top over cos squared theta on the bottom. And I can write the left side as 4 sine theta over cos theta times 1 over cos theta and this is gonna be 4 tan theta secant theta. This is indeed equal to 4 tangent theta secant theta, and the trig identity is proven. All right. I said that was going to be the last one, right? But I'm feeling like doing one last one. This is number 8. Sine theta plus cosine theta is equal to, or is it equal to, sine theta over 1 minus cotangent theta plus cosine theta over 1 minus tangent theta. So the left side, I don't think I can simplify it any further. It's just sine theta plus cos theta. I can't combine the terms, and yeah, I'm going to stick with the right side. I'm going to start by simplifying the right side. The left side is in terms of sine and cosine, so I'm going to make the right, I'm going to write everything in terms of sine and cosine on the right side. So sine theta over 1 minus cotangent theta, that is cosine theta over sine theta, plus cos theta 1 minus tangent theta, that is going to be sine theta over cosine theta. And to get rid of this fraction, these fractions on the bottom here, for this first fraction here, I'm going to multiply this by sine theta over sine theta. So that way when I distribute this to both terms here, using the distributive law, this sine theta will cancel with this one here, which will eliminate the fraction. So the second one here is going to be cos theta over 1 minus sine theta over cos theta. And I'm going to multiply by cos theta over cos theta. So that way, when I distribute the cos theta on the bottom, it will cancel this one here. So when that happens, so for the first fraction here, on the top here, I have sine theta times sine theta, that's sine squared theta. On the bottom, so sine theta times 1, that's sine theta. And on the bottom, the sines cancel, so I'm left with minus cos theta. And then plus, on top here, I have cos squared theta over, and if I distribute the cosine theta, that is going to be cos theta minus sine theta. And these denominators are the same. This is just, if I factor out a minus sign, this can be made the same. So I'm going to leave this first term alone, sine squared theta over sine theta minus cos theta plus cos squared theta over, if I factor out a -1, this is going to be sine theta minus cos theta. So this is sine squared theta over sine theta minus cos theta minus cos squared theta over sine theta minus cos theta. And they now have the same denominator, so now I can subtract the fractions. So this will be on the top here. So the bottom will be the same, sine theta minus cos theta. On the top here is sine squared theta minus cos squared theta. I subtract the numerators. And this is, again, a difference of squares pattern. Sine squared theta minus cos squared theta. That means that I can factor it as sine theta plus cos theta times sine theta minus cos theta all over sine theta minus cos theta. And now this factor, sine theta minus cos theta, cancels out with the 1 on the bottom, and I am left with sine theta plus cos theta, which is what the left side is. So we have shown, or we have verified, this trig identity. All right, that's all for now. I hope you got something out of this video. Take care.